Okay. Is my voice is audible? Okay, right. Now I'm going to teach you the signals and systems for this particular semester. Okay. So as we already discussed about the main objectives and the course outcomes in the yesterday's class. So I think we have faced some technical problems yesterday, but now today again I am going to face the same problems. So that is why I am going to rectify the same mistakes what I have faced in the yesterday's class. Okay. So basically this is the basic Zoom version. So which comprises of only the duration of the class is 40 minutes. So let us not waste our time. Okay. So before going to proceed the actual content of the subject, first of all, let us discuss about the main objectives of studying the signals and systems. See, objective is nothing but the main aim, what you are going to achieve by studying this particular subject. So basically, already I told you that signals and systems is not our core subject. So even though this is not a non-core subject, but this we will find the applications everywhere of our electrical applications, our electrical fields. Okay, so that is why it is very very important. And I'm not going to say this is a theory subject, and I'm not going to say this is a completely problematic subject. This is a combination of problematic as well as theory subject. So we are giving utmost preference to the problems. Why? Because signals and systems completely the depends on the mathematical foundation what you have studied in the earlier semesters. I think already you have completed the Fourier transforms, Laplace transforms, and jet transforms also. So you know how to apply or where to apply the Fourier transforms and Laplace transforms. See, transformation is very very important tool for analyzing the system response. We are having two types of systems, continuous time systems and discrete time systems. So far you have studied only the continuous time systems, you have not studied about the discrete time systems. So what are the classical approaches which are available to study the continuous time systems? Already the subject control systems, I think control systems, right? So in the control system subject you have learned about the classical approaches for studying the stability concepts of the continuous time systems. So what are the classical approaches which are available? So Bode plot, Nyquist plot, polar plot, etc., etc. All these are classical approaches only to understand or to study the behavior of continuous time systems only. But those classical approaches are not applicable to nonlinear systems are discrete time systems. So for these studying the analysis or for analyzing the discrete time systems, you need a separate mathematical tool, that is jet transformations. Okay. So whatever it may be, we'll see one by one once if we start the actual subject. So the main objectives of signals and systems is to introduce the terminology of signals and systems. First, the student is able to identify the differentiation between signal. What are the different types of signals which are available, and what are the different types of systems which are available. After that, we are using the Fourier tools, introduce the Fourier tools to the analogy between the vectors and signals. And after that, we to introduce the concept of sampling and reconstruction of the signals. So sampling is a process of converting the continuous time signals to discrete time signals. And after that, again, you are going to reconstruct the original signal from the obtained signal. And later, to analyze the linear systems in time and frequency domains. So we have discussed about this point in the control system. See there, the frequency domains are very very important. In some cases it is not possible to analyze the systems by considering time domains. So in that particular case we are going to convert the time domain functions to frequency domain functions, and after that we are going to analyze the same systems. Okay. Later, the jet transform. See, jet transform, just now we discussed about the jet transformation, which is a very, very essential mathematical tool to analyze the discrete signals and systems. So these are the main objectives by studying this particular signals and systems. I'm going to say that objective is nothing but the aim. What is your aim by studying this particular subject? Okay. Later, we are going to see the outcomes. What is the outcome of the signals and systems? So here I am going to introduce 6 outcomes which are related to the 6 chapters. So chapter number 1, this is a basic introduction. So in this particular introduction, you are going to study about the signals and systems and principles of vector spaces and concepts of orthogonality. So by studying the chapter number 1, student will be able to characterize the signals and systems and principles of vector spaces and concepts of orthogonality. Later in the second chapter, you are going to analyze the continuous time signals and continuous time systems using Fourier series, Fourier transforms, and Laplace transforms. So we already know that all these types of transformations, Fourier transforms, Laplace, etc., are applicable to continuous time systems only, not for discrete time systems. Please remember this point. And apply sampling theorem. Apply sampling theorem. So what is the sampling? See, sampling is a process of converting continuous time signals to discrete time signals, and again the reconstruction of original signals from the obtained discrete time signals. And later, student will be able to understand the relationships between the various representations of LTA systems. Okay, so linear time invariant systems. Understand the concepts of convolution, correlation, energy and power density spectrum, etc. Their relationships. Apply the transform to analyze the discrete time signals and systems. Okay. This is a very important outcomes, learning outcomes from each and every chapter. So that is why you are having 6 chapters, and from each and every chapter you are going to get one outcome. What you are going, the student will able to get the information, right? Now let us quickly start our actual topic, that is unit 1, that is introduction, signals. So before going to start the chapter number 1, first of all, what are the topics that you are going to learn in this particular chapter? So as I already discussed about the learning outcomes of chapter number 1, so the first one is characterize the signals and systems and principles of vector spaces, concepts of orthogonality. So these are the subtopics that are included in chapter number 1, and let us see the basic definition of signal. So basically the signal can be classified sorry, basically the signal can be defined as any physical quantity which varies with respect to an independent variable like time, arc, space, etc. That means indirectly I am saying that signal is a physical quantity which contains some information, and that too which varies with respect to an independent variable. So here time and space are two variables which are independent variables, which are classified into independent variables. So that signal wave, suppose if you are relating the signals and systems concept to our electrical field application, so in our electrical engineering we are going to identify different types of signals in networks and etc. where so many subjects, so like voltage signal, current signal, power signal, energy signal, okay, etc., etc. Suppose if you are considering the voltage signal, what type of information does it contains? It contains the information regarding the amplitude of voltage. Similarly, current signal, so it contains information of current. Power signal, it contains the information of power. Energy signal, it contains the information of energy. Likewise, the signal can be defined as any physical quantity which varies with respect to an independent variable. So most of the time you are considering an independent variable is a time. Okay, now comes to the actual classification. How many types are available in the signals? So signals are basically different into different types. So here the different types of signals are presented. So signals are classified into different types based on the independent variables. So if any physical quantity which varies with respect to time, only one independent variable, it is one-dimensional signal. So basically the signals are two types, one-dimensional signal and multi-dimensional signal. So here one-dimensional signal and multi-dimensional, both signal definitions are same. But here we need to remember one point, that is in one-dimensional signal, we are considering only one independent variable, the physical quantity which varies with respect to one independent variable called one-dimensional signal. If any physical quantity which varies with respect to time more than one independent variable, that means multi-dimensional signal. So here the best example for one-dimensional signal is a analog signal. So here please see here, one-dimensional signal, a triangular waveform, sine waveform, trapezoidal waveform, so many waveforms are existing, cosinusoidal function, cosinusoidal waveform, all those waveforms are comes under one-dimensional signal. Why? Because most of the times we are considering only time on x-axis and x of t on y-axis. So here a sinusoidal waveform is represented and x of t has been taken on like a y-axis. So here please do remember one point. If I am considering x of t is a voltage signal, that means v of t, okay, v of t. So that signal carries information regarding the voltage, amplitude of voltage. So if I have taken one complete cycle like this, so from 0 to 2, now at this first half cycle, if I mark it as 1, so 0, 1, 2. So in between 0 and 1, the signal is continuous in magnitude. You do not find any discontinuities. So now tell me, how many points are existing in between 0 and 1? Okay, of course, exactly. In between 0 and 1, you will find infinite number of values. So infinite number of values are existing. Now, if it is it possible to find or is it possible to determine the amplitude of this x of t at t is equal to 0.5? Yes, correct. 0.55, yes. 0.556, yes, exactly. So in between 0 and 1, you will find infinite number of values. So in between 0 and 2, infinite number of values are existing. So there is no discontinuity at all in this particular complete cycle. So that is why this x of t is nothing but a continuous time signal. Okay, so continue, there is no discontinuity at all. So example for multi-dimensional signal is pictures. All the three-dimensional pictures are comes under the category of multi-dimensional signals. So three-dimensional pictures means obviously two-dimensional means x-axis and y-axis. Three-dimensional means x and y and z-axis also. See, already you have studied engineering graphics. In engineering graphics, we have studied three-dimensional uh, three-dimensional figures. So there we are using x-axis, y-axis, and z-axis. So all those signals are comes under this multi-dimensional signals. Now come to the actual classification of continuous time signals. So not continuous time signals. See, the basic classification of signals are only two types. The first one is continuous time signals. Second one is discrete time signal. Now see the definition of continuous time signal. So it is defined as the signal which has the magnitude for all values of time from minus infinity to plus infinity. So here the example is also already given, that is sine waveform in the above figure. So here you please look at this figure x of t, which is a shape, sinusoidal waveform shape. This will repeats from minus infinity to plus infinity. But here for only easy understanding, I am representing only two cycles, right? Now this is the example for continuous time signal. See the definition, it is defined as a signal which has a magnitude for all values of time. See, already I have explained that this is 0 and this is 1 and this is 2. So in between 0 and 2, you will find infinite number of values. There is no discontinuity at all. So it is possible to determine the magnitude of x of t at any point of time in between 0 and 2. Okay, but that is not in the case of discrete time signal. And let us see the definition of discrete time signal. The signals that are defined as are the signal which has magnitude for all values of time are only at particular instance of time. So which are continuous in amplitude and discrete instance of time. So discrete instance of time means, suppose if you are considering the same case, again we are going to define the sine waveform from 0 and 2, in between 0 and 2. So now the shape of the waveform is not like this. You are having amplitudes only at the predefined values of time or instance of time. Defined instance of time. Different instance of time is 0 or 0.5 or only at specified values of time only. Specified values. Okay. Only at a specified values of time, right? So that is the basic difference between discrete time signal and a continuous time signal. So here the representation is also given. So discrete time signals are denoted with x of n and the continuous time signals are denoted with x of t. Okay. So here there is a possibility of converting continuous time signal to discrete time signal. So what is the formula we are using for converting the continuous time signal to discrete time signal? X of n into capital T is equal to x of t, where t is equal to n into t. What is n and what is capital T? So here n is nothing but an integer. N is nothing but an integer. Here capital T is nothing but sampling period. It denotes that at what instant of time you are going to sample the waveform. Sample the waveform means obviously we are going to get the information at that particular instant of time. Okay. Now this is the basic formula we are using. Now let us see the problem. Okay, so as I already told you that this subject is completely problematic subject. The subject is completely problematic subject. Okay. So basically, this is a problematic subject. Means definitely you must have some piece of paper and pen to solve the problems what I am showing on the PPT presentation. Why? Because it is not possible to look at the PPT of solving the problem. So please see the problem. Sketch the continuous time signal x of t, which is equal to 2 into sine pi t, for the interval is also given, that is 0 less than or equal to t less than or equal to 2, and sample the discrete time signal with the sampling period capital T is equal to 0.2 seconds, and sketch the discrete time signal. Okay, just wait a moment. Okay, is my screen is visible? Is my screen is visible? Okay. Okay, now this problem is completely related to the basic information what we have studied about the signals. So here you have been given x of t is equal to 2 sine pi t in the interval 0 to 2, and you are asked to draw or sketch the discrete time signal. That means you are having the information regarding the continuous time signal, and you are asked to determine uptime or sketch the discrete time signal. So this problem will give you the information of converting given continuous time signal. Given continuous time signal can be converted to discrete time signal. Okay, and we'll solve this problem later on tomorrow's class. We shall see it in the tomorrow's class, but please try to understand the concept. Okay, don't concentrate on your attendance, just concentrate on the content what we are going to deliver. See, basically this version is completely this type of teaching methodology is completely new to you, and as a faculty this is also new to us. Okay, so please try to understand the technical problems what we are facing. Okay, meanwhile we will try to rectify, we will try to face the same technical problems here also. Please try to understand the situation. Okay, now please, if you are having any doubts, you please ask me, or you can personally message me through to WhatsApp account. Already my WhatsApp number has been given in the group. Okay, and it is not possible to pass the information regarding the content, course content or delivery content to the groups. Okay, if anybody wants the information regarding the soft copy or material, you please personally message me so that I will give you. So it is better to have a CR in your group. Okay, so that CR will communicate with me. Definitely I will provide the material or the contents which are available with me to the CR, and the CR will share the content or whatever it may be regarding the information regarding the subject that will be delivered to your mails or to your accounts also. Okay, so that's all for today. Remaining will continue in the next class. I mean, in tomorrow's class, we shall solve this problem, and we are going to again find out the different types of signals which are to be produced in the laboratories. Okay, so that is the end of the session. Okay, that is the end of session. We shall discuss it in the next class. So please have a look at the contents what we are delivering in the through the video lectures also. Okay, so videos are also available. Please try to look at the same. Okay.